Imagine walking into your living room. What do you see? A television, a couch, a bookshelf, right? Now think of these household items as Java objects. Just like your television has attributes such as brand and screen size, and behaviors like turning on and changing channels, a Java object possesses fields and methods. Fields are the attributes of the object, the details that define it. Methods, on the other hand, are the actions or behaviors that the object can perform. If we consider a Java object as a television, then the brand, screen size, and current channel would be the fields, while turning on and changing channels would represent the methods. In essence, every object in Java is like an item in your living room, each with its own set of attributes and behaviors serving a distinct purpose. Just as every item in your living room has a purpose and function, so does every object in Java. Before we can have a television, someone needs to design it, right? The same goes for Java objects. Just like the design for a television determines its brand, screen size, and how it operates, a Java class serves as a blueprint for creating objects. Consider a Java class as a sketch or blueprint of a television. This blueprint lists the attributes or fields a television might have, such as the brand, screen size, and current channel. It also details the actions or methods a television can perform, like turning on, changing channels, and adjusting the volume. Let's look at a simple Java class named Television. In this television class, we have three fields: brand, screen size, and current channel. We also have three methods: turn on, change channel, int new channel, and adjust volume, int new volume level. Now, using this blueprint, we can create different televisions, or in other words, instances of the television class. For instance, let's create a Samsung 55 inches TV. Here, Samsung TV is an object of the television class with its own brand, screen size, and current channel. Using our class, we can create as many televisions as we want, each with its own unique attributes and behaviors. In real-life applications, Java objects represent various entities like users, products, accounts, etc., and manage their data and operations. For example, a banking application might treat each customer as an object with fields like account number, balance, and methods like depositing and withdrawing money. So a class is essentially a blueprint or a design for an object. It's a detailed plan of what an object should have and what it should be able to do. With this understanding, we can create any number of objects with the same basic structure, but different values, just like different televisions in our homes. Now that we have our television blueprint, let's build a television. Imagine we're in a factory. We have our blueprint, the television class, and we're ready to manufacture our first television. In Java, this process is called creating an object. To create a television object in Java, we use the keyword along with the class name like this. This line of code creates a new object of the class. Now, our Samsung TV is just an empty shell. We need to set its attributes or fields. We do that like this, and here, we're setting the brand to Samsung, the screen size to 55 inches, and the current channel to 1. Next, we need to use the television. In Java, using an object means calling its methods. We can turn on the TV with and change the channel with. And there you have it. We've created a specific television, a Samsung 55 inches TV, in our Java program. This television is an object, a specific instance of the television class with its own brand, screen size, and channel. We can create many more televisions, each with different attributes. Maybe we want a Sony television in the living room, an LG television in the bedroom, and a Panasonic television in the kitchen. Each television is a separate object, but they all follow the same blueprint, the television class. Scene script? But why do we need objects in Java? What's their purpose, you may ask? Well, let's dive into the practical applications of Java objects to understand their significance. Java objects are like actors in a play, each playing their own role, each equipped with their own set of attributes and behaviors. Now think of a complex software application as a vast stage play with numerous characters involved. Let's take a banking application, for instance. Each customer can be represented as an object within this application. The customer object might have attributes like account number, account balance, and transaction history. The behaviors could be depositing money, withdrawing funds, or transferring money to another account. In the code, it would look something like this. And just like that, we've created a blueprint for our customer objects. Creating a new customer object would then look something like this. In a similar fashion, we can create objects for other entities like accounts, transactions, bank employees, and so on. Each object handles its own data and operations, which makes our code more organized and easier to manage. But that's not all. Objects also help us to write reusable code. Once we've defined a class, we can create as many objects as we need from it. This saves us a lot of time and effort in the long run. To wrap it up, Java objects are the building blocks of Java programs. They represent real-world entities, manage their own data and operations, and help us to write organized, reusable, and efficient code. Objects make our Java programs more organized, efficient, and manageable. So let's embrace the power of objects and bring our Java programs to life. Let's take a moment to review what we've learned. We started our journey by understanding that Java objects are like household items. For instance, we compared a Java object to a television. Just like a television has attributes such as brand, screen size, and channel, a Java object has fields and methods. We then moved on to the concept of a class in Java, which is like a blueprint for an object. This blueprint describes what every object, or in our example, every television, will have in common. We defined a class named television with attributes like brand, screen size, and current channel, and behaviors like turning on, changing channels, and adjusting volume. Next, we learned how to create a specific object from a class. We created a Samsung 55 inches TV object from the television class. This object or instance had its own brand, screen size, and current channel. This process can be repeated to create any number of objects from a class, each representing a different television in our home. We also touched upon the practical applications of Java objects. In real-world applications, Java objects are used to represent various entities like users, products, accounts, etc., and manage their data and operations. We gave an example of a banking application, where each customer can be an object with attributes like account number, balance, etc., and behaviors like depositing and withdrawing money. This journey through Java classes and objects was intended to simplify these concepts and make them relatable. The core idea is that every Java object, like every item in your living room, has a purpose. And behind every object, there's a class or a blueprint. Remember, just like every item in your living room, every Java object has a purpose, and behind every object, there's a class or a blueprint. So keep practicing, keep coding, and you'll master the art of creating and using objects in Java.